Hi, welcome to our last example for 3.3 rational exponents. In this example, we're just going to solve a problem involving a rational exponent. It says the following formula relates the volume V and the surface area S of a sphere. So you can see this diagram. We have this sphere vessel. It looks like a tank of some sort. And this equation here relates the volume, so how much water you could fit in there, with the surface area of this tank. So all the red material that encapsulates that tank. So that's the equation. A little bit complicated. We see we have a negative exponent here, and we also have S in here. That's the surface area. So it shows the volume is a function of the surface area. So you could just plug in S, a number for S, and calculate the volume. In fact, that's actually what it's going to ask us to do. It says find the volume to the nearest cubic meter of a spherical holding tank with a surface area of 100. So this is just kind of seeing if we can handle the rational exponents. So that's raised to the negative 1/2. This is over 3. And then it says times S, which is 100. And then we have that raised to the exponent 3 over 2. So we're not going to get a nice, exact, simple answer because we have pi in here and we're going to have to evaluate this. That's why it's saying to the nearest cubic meter. So we'll round up or down to the nearest whole number depending on what we get. Okay, so we could probably just plug this right into our calculator because we're not going to be leaving this as exact. So there's not really any reason to do much with this. So if you wanted to work a little bit algebraically, you could evaluate this last part, 100 to the exponent 3 over 2. So if I were to do that, I would rewrite this as 100 raised to the exponent 1/2 and then cubed. That would give me 10 cubed because the square root of 100 is 10. And 10 cubed just means 3 zeros. So that's just 1,000 here. So if you want, you can even write it like that. Put that all in your calculator in one shot. So, okay, I'm going to go ahead. I'm going to do that. 4 to the pi, 4 times pi, all that raised. I put that in a bracket to the exponent negative 1/2. You can write in negative 0.5 if you want. That'll keep it nice and easy. Then multiply this whole thing by 1,000. Okay. And then I can set up my brackets here to grab all of that whole number, and then divide all that by 3. So depending if you're using a TI-84, you're going to probably want to enter those brackets in ahead of time. And I got 94.03, so we're going to say approximately 94. We'll round down. Okay, and that's supposed to be volume, so I'm going to say meters cubed. All right, that's it for this section. You'll find the homework in the class notebook. And anyway, I hope you found these helpful. I'll talk to you guys later.